In this video tutorial, we'll introduce the use of Snort as an intrusion detection system and a tool that will help us to alert on traffic patterns that we specify within network communication. So to get things started, we'll be using the Kali VM and our target. We will go in and change the network interface card on Kali to allow us to download the Snort package. We'll go in and set up Snort. We'll configure Snort, and then we're going to launch different tests to demonstrate the Snort capability as a network intrusion detection system. So to get things started, we're going to go ahead and change the Kali network interface to be actually NAT, network address translation, and that will actually tie into our physical NIC, allow us to go in to the internet and download different packages. So we're going to go in and obtain a new address from our DHCP local instance, and this address is going to vary for your own setup, but the way to test and make sure it's working is we can fire up the Firefox browser and go to a site like google.com, and if you can actually go to Google or another website, CNN.com. Who goes to CNN.com anymore? But this will be an indicator that you have connections properly set up. So once you have an internet connection, we're going to go ahead and download Snort. So you're going to leave the default option here, and once the download is complete, we're going to start looking through the Snort options, the actual configuration file. Before we start messing too much with the configuration file, it's a good practice to make a backup of that file. So because I kind of did it very quickly, the actual command is apt-get install -y to bypass the menu. I have to type in Y to continue. It's kind of a pre-configured switch, and then I tell it to install Snort. So from here, what we're going to do is we will go in and use we're going to copy the location of the default Snort config file into the same directory with an extension called backup. So we're just making a backup of the original file, okay? And then the next thing we're going to do is open up the configuration file. We need to make a few adjustments, okay? So the first adjustment, the file itself provides the different options, and it's broken down into categories, and the different categories kind of walk you through a logical, methodical process for configuring the file. We're not going to tweak the file too much. We're going to set up a couple variables, and we'll make sure that for the simple proof of concept, it's really easy to follow. So what we need to do is we need to tell the network intrusion detection what is the source that we're protecting, what is the address that we're concerned about. So we're going to go into the line with HomeNet. So the easiest way is, wherever you are on the page, just go into HomeNet, Control F, or you can do, if you go into the search menu, click Find, and you see the actual keyboard shortcut is Control F. So from there, we're going to go into the IP variable. HomeNet equals, instead of any, we're going to set it to the IP address that we'll use for Kali. In our instance, 56102. Okay, 56102. The other thing we're going to do with the config file is we are going to look in and find the location of the rule path. The rule path is essentially the path to the different rules that we use to determine when the intrusion detection is going to raise an alert to our attention. The rules are also helping us define the patterns for when this alert will be triggered. So if you look into the rule path, the default path for this rule for a Linux system is itsy snort rules. Okay, so from here what we need to do is we're going to go in and we will add a custom rule. Okay, so scroll down into the rule path and we're going to go at the very bottom here. So if you notice, comment lines have a symbol in front of them. Now we're going to include here, we're going to do the same rule path, but we're going to create some custom rules for us. Okay, so with these custom rules in place, we're going to close this file, we're going to save it, so make sure you save it. Now at this point we'll also go ahead and create the custom file. Okay, so leafpad itsy snort rules, and we need to create a file called custom rules. So with the leafpad text editor, we're going to go ahead and create some custom rules. Okay, so the way that the rules are set up, we need to define action. In our case, can be an action like alert. I'll provide actually a reference link into some of the syntax and background information of working with Snort. So the next thing we need to do is define the source IP, and in our case it's going to be any. What is the source port? The next thing we need to do is the direction. So we're going to be alerting on traffic coming from any source. We got to tell it to what destination, so any IP address on any port. Okay, the next component is we need to define the message we're gonna trigger on, and we're gonna do a custom trigger, and we're gonna call it let's make it more visible, and we're gonna use a simple string like val and then detect it. Okay, the actual message needs to be enclosed in quotes. The end of the message needs to be finished with a semicolon. Or actually, we're going to close the parenthesis and then use a semicolon. Then we need to specify the content. So what is the content that I want to be triggering on? Okay, it's going to be val. Okay, a couple other things we need to specify is the SID, or the signature ID. What I use for signature ID, I'm going to ask you to do the same, is use the current year, month, day, and then any other iteration of an alert is we're gonna be adding one numeric character. So the following alert is gonna have 0, the third one 1, fourth one 3, and 2 or 3, and so on. Okay, so we're gonna keep it simple like that. So we need to have another semicolon, and then optional we can provide a revision, and then the actual rule ends with a smiley face. And I think I gotta reuse this from here. Okay, so let's see, let's go ahead and set this up. We will save this file. So the next thing we need to do is we'll go ahead and set up, and it looks like my lesson plan disappeared, so let's bring up my notepad and figure out the options that I have here. So Let's see, downloaded, copied, created the custom rules, testing the snort. Okay, so what we need to do is we created the custom rule. We need to test that custom rule. But before we do that, we need to actually understand and test the configuration and make sure that the rule is actually working correctly. So to start snort and do the test, what we need to do is invoke snort -t to actually test. -I is the network interface, in this case ETH0. And how do I know that? If config, and look at this, ETH0, but I made a mistake and I haven't changed my IP address, so I haven't moved it back to NAT. So let's do this. Settings, network, I'm gonna go on host only, and okay. From here we're gonna do if config. We need to set our IP address manually to 56.102. And now if we do if config, we noticed here that we have the IP address configured. So from here we will do a test of snort to make sure that the rule that we have in place is actually accurate. If there is consistency error, if there is a syntax error, snort will try to give us some clues that we can use to correct the rule or the configuration file. So snort-t, we need to specify the interface, and this is ETH0, and I see this from here. The next thing is we need to specify -c for the config file. So what is the location of the modified config file? Okay, and even with this, and it looks like, look at the protocol. Okay, so look at the error message that I have. Okay, look at this. So when I created the rule, I made a mistake. And this mistake is, we're going to go ahead and get the leaf path, and I'm using the up arrow to go back to my latest command, alert. So I did the source and destination IP, but I forgot to include the protocol. The protocol is going to help us to narrow down the inspection, and there's a number set protocols that Snort can inspect. So we need to specify is we're going to use the transfer control protocol, TCP. Okay, so let's see if with this modification, Snort now is actually liking what we have in place. Snort successfully validated the configuration. It looks like it's working. So the config file had a rule. The config file itself was okay. There weren't any error messages, but the custom rule that we created had a syntax error, and you were running the test, we're able to identify this and correct it. So now that we have the rule corrected, we need to set up a test. Okay, and we did the test of the configuration. It looks like the next two things, there's two ways, major common ways that we can invoke Snort. So we can use an output directly to the console. So when there is a detected rule match, there will be an alert, and the alert is going to be displayed directly into the window that we're working from real time. The other option is to output the alert to a file, a log file that we can create. Okay, so these are the two different options we're going to experiment with. But before we do this, we need to actually set up a reverse shell for the proof of concept so we can actually demonstrate that. Okay, so let's do this. So from the Kali, I'm going to open up a different terminal window. Okay, and in here I'm going to invoke netcat. I'm going to set it to listen on port 49s, and then I'm going to do a reverse shell to anyone who connects. Okay, and I will start the let's see, Metasploitable, making sure that I sign in. msf admin, and if config, want to make sure that I see what my IP address is. So in this case it's 56101, and I don't remember if that's the correct configuration that you have or not. If you need to change it, just make sure it's sudo ifconfig, and then you type in what the IP address that you have in the very first lab is supposed to be. You can do it 103, you can do it whatever, it doesn't really matter. So from here, what we need to do is invoke 68 netcat to connect to our reverse shell on Kali. Okay, great, so we're connected. So now we can actually proceed with the experimentation. So we did the test configuration of Snort. I'm going to change the parameter to console. Okay, so we're going to record the output directly to the console. Okay, if things are well. So this blinking cursor is a good indicator. Now if we go in and launch an action that we wrote a Snort rule for detection, it should come up here. It should show us an alert. So the way we're going to simulate this, if you remember, the rule that we wrote was rules, custom rules. So we're going to alert on the content val. Okay, the content val. So if our Kali machine sees val in the network communication, it should raise an alert. And let's see if the rule we set up is working appropriately. Okay, and there it is. So I just typed in val. So I passed the val string from the metasploitable target to the actual Kali, where we have a reverse shell. And what happened is we triggered the rule that we have in place. So we know the intrusion detection is actually working okay. Now let's go and experiment with some other rules. Let's go ahead and create a rule for ping. So if you were to go in and ping, we're gonna actually let's do this since we have the shell established. Let's go ahead and create a rule for ITSI passwd. So I'm gonna copy this and I'm gonna go ahead and paste it here. So the next rule we're gonna work with is we're gonna do the alert, the same protocol, any source IP, any destination protocol, and notice the different symbol. So it could be bidirectional, so it's going to be coming from the source to the destination or from the destination to the source. It doesn't matter. And then the message is going to be simulated. ITSI passwd. I just removed this so it's easier to see. ITSI passwd access, and the content is going to be kind of interesting. So we used a plain string like val, and now we have a symbol, this 2f ITSI2f passwd. 2f is actually the hexadecimal representation of a slash. Okay, and because the encoding and the way the Snort interprets some of the characters, in order to make sure we have the detection of the ITSI passwd, we need to use hexadecimal representation, and then any hexadecimal value needs to be enclosed with the straight line, the straight symbol, or whatever you want to call it. Then we need to have the actual ID, and each signature ID needs to be unique. So you got to make sure whatever you have For the first signature ID, it's different than the second, third, and so on. And then the revision doesn't matter. That's the actual revision of the rule itself. So once we have this, we can save it. Okay. And now, since we have the shell established, let's go in and see if the rule is working correctly. What we need to do here is invoke a command like passwd. Okay. So we see the val detected, but we don't see let's go and review the rule. So there's 2f, 2f, passwd, making sure the rule is correct from any. Okay, let's see if the syntax that I have typed in is correct. So let's just pass passwd, and it's not throwing an actual detection. Okay, so I figured out what happened. I had a character in the rule that Snort did not know how to interpret. So what I did is I had to rewrite the rule, and I saved both of the rules so we can compare. So the first rule that I had and didn't work is it didn't for some reason like the star star itsy passwd star star. So all I had to do is add another string in front of it and then do itsy passwd. Okay, and then what I did is I restarted Snort, and I had this actually alert that come up. So let's go ahead and simulate the alert again. We're going to go into here, we're going to execute cat itsy passwd. You see how it came up? So writing the Snort rules is very, very particular. So there are characters that Snort may not like, and it's going to be kind of trial and error process of you figuring out where the mistake is. It could be missing double quote, it could be a missing semicolon, it could be a missing parenthesis, it could be a character that Snort did not know how to interpret. Okay, so what you have to do is when you have a rule that you're not quite sure and it's throwing an error, you can comment that out. Okay, and this will help you along with the process and kind of help you determine where the mistake is so you can backpedal and fix it up. Now we did the itsy passwd. If we were to throw in another example, is we can add a rule for the shadow file. Okay, I'm going to copy this directly to save time and make sure I don't make a mistake with my syntax. And what I have here is we're going to similar rule is what we're doing is we're going to notify on the shadow file. Okay, and we have the content is the word shadow. I wanted to show you something and provide hopefully a lesson learned. So we're triggering on the word shadow. Okay, so we're going to save, and obviously I need to control C. Control C will interrupt Snort, and then I need to restart it again. That's the best way to, after you apply different rule changes, to save them and reinitiate the process. So eventually this will stop. If not, we can force it. If this happens for you, if Snort is not responding, we just close the terminal and start over. We're going to open up a new one, and let's see, snort and -a. We're going to output the content to the console. We need to specify our interface, our config file, which is etc snort conf. Okay, and from here we create a new rule that will test, and it's cat etc shadow. Okay, and you see how this came up? Simulated shadow. Now let's look into the rule itself and see what it talks about. So we have obviously the date and time stamp. Next, we have the actual rule ID. So you see these characters here. So you have the rule ID, you have the revision, you have the actual alert, you have the priority, so we can custom the priority, you have the protocol, and you have the direction. So we see that the system with IP address 101 and then this random port is connecting to our Kali VM, which is this IP address on the specified port. Okay, so with this in mind, we tested different rules. Now what we will do, I'm gonna create actually a different video tutorial. We're gonna experiment with a saved packet capture, and we're gonna create a couple additional rules, and then inspect the packet capture with the Snort intrusion detection system as well as Wireshark to determine what happened. Before we go there, I wanted to show one more thing. So in the config file, we can specify a log location for Snort, or we can provide on the fly logging capability of Snort. So let's do this. So I'm going to interrupt Snort, and let's see if it actually successfully interrupts. Control C, and if it doesn't, we're going to start it over. And let's punt it. There you go, it did it. So I'm going to use the up arrow. So instead of outputting it to the console, I'm going to specify a log. Actually, before we do that, I need to create the log file, and I'm going to create it to the desktop of my root user account. So I'm going to use the touch command, specify the path, and then log is the file name. Okay. So once I have this created, I can verify that it exists. You know, I see the log there. Okay. So what I need to do is tell the location of the log that I just created. That's called log. Okay. So now I'm also going to add the binary. So I want to record the content into a binary format. That will provide some additional information about the communication. Okay, so and I'm gonna hit enter, and it looks like alert file log alert, not a directory. Okay, so it looks like I made a mistake, and what I needed to do was create a directory, okay, and not just a file. So we're gonna do make directory root desktop, and we're gonna call it log. Oh, file already exists, yeah, because it's a file, not a directory, but you know, everything in Linux is treated as a file. So let's get rid of it and go and recreate it as a directory. So what the log here is actually, Snort is looking for a directory, not just a file. It will populate its own files like alert or snort log and so on once the directory is available, and it's available for writing by the user you're running Snort with. So let's run again. Remember, if Snort doesn't like something, we'll throw an error and then we can correct it. Okay, so we got to start it, and let's go ahead and do a simulation. So we know that we have a rule for etc passwd or the shadow file, and let's do this. I'm not sure if my shell fell asleep. Let's figure out what's happening here. ls, so this is working. Cat etc passwd. Now notice this. Because we are logging the output to a particular folder, we're not going to see anything in here. So the way we can monitor the content of the log file is we can use the telf root desktop log. It's going to have an alert. Okay, so here's where the actual alerts are, and this is the last entry, which would have seen it here. So since we're using the telf command and then we're tailing the contents, the last input into the alert log, let's see what that looks like real time. So we're gonna go and execute, I don't know, play with the string here, val. Now for your assignment, make sure that you use your own name. You don't have to use my name. You can use any test string. Okay, and we saw in the telf that this was triggered. So you see similar information. You have some additional information about the packet itself. So it's the time to live. We have the actual ID, the IP length, and we're seeing the sequence number, we're seeing the no operation, we see the window, and TCP length. So with this in mind, Snort is as good as we make it, is as easy or as painful as we put the time and attention to configure it. Snort can only notify us for things that we tell it to look for. It's a signature based, it's not necessarily behavior. Even behavioral based intrusion detection systems are looking for some type of pattern, some type of a signature to be able to put pieces of the puzzle together and raise an alert.